Hello everyone. Today we are going to be talking about kinetic energy. Translational kinetic energy is the energy an object possesses due to straight line motion. So the energy an object has because it's going in a straight line. Now you should know the equation, which is kinetic energy equals 1/2 times mass times velocity to the power of 2. You should keep in mind that mass will generally be in kilograms, and that kinetic energy is often measured in either joules or kilojoules. Kinetic energy is a scalar quantity, which means it has magnitude but does not have direction. And it is always positive because of the v squared at the end. That v squared at the end will turn any negative value into a positive value. If velocity doubles, kinetic energy increases by a factor of 4, and if velocity triples, kinetic energy increases by a factor of 9. Alright, so I've got a car here. Now, this is a pretty small car. I'm not exactly sure what its mass is, but it can't be very much. But we're going to say, just for the sake of this example, that its mass is 5 kilograms. Now, it definitely isn't, right? It's very, it's not heavy at all, but we're just going to say, for the sake of this example, that it's 5 kilograms, right? And let's say that this 5 kilogram car is moving across our screen at 10 meters per second. If that's the case, how can we find the kinetic energy of the car? Well, we are going to do 1/2 times the mass, which is 5 kilograms, times velocity squared. So that'll end up being 1/2 times 5 times 10 to the power of 2. So we know 10 to the power of 2 is going to be 100. 5 times 100 is 500. And then half times 500 is 250. So we can say then that this car, moving across our screen at 10 meters per second, has a kinetic energy of 250 joules. Now, something that's important to note about kinetic energy is that different observers may measure different kinetic energy values, right? So let's say, for instance, I have this car, right, that we had in the first example, but I've also got this dinosaur. Now, in this example, we're going to say that both the car and the dinosaur are moving along at the same speed, right? And maybe they are still both going 10 meters per second. Now, we obviously know that this car is moving with it has a kinetic energy of 250 joules, right? But let's think about it from the perspective of this dinosaur. Now, that dinosaur and that car, they are moving across the screen at the same speed, which means that from the dinosaur's perspective, the car wasn't moving at all, right? Because motion is examined, like you see motion in regards to a reference point, right? So the car compared to the ground is obviously moving, but if we hold these two together and we move them, the car in relation to the dinosaur isn't moving. You see that? So when we're writing it out, if we're from the perspective of the dinosaur and we're trying to calculate the kinetic energy, the velocity is going to be 0. And because we multiplied the velocity by the other variables in the equation, the entire thing is going to be 0. So from the dinosaur's perspective, the car has 0 joules of kinetic energy and actually appears to be at rest. Whereas from our perspective, obviously watching from afar, they both appear to have a kinetic energy of 250 joules, right? So it's important to note when you are finding kinetic energy that you need to have a reference point. You need to really think about what your reference point is, because the kinetic energy depends on the observer's frame of reference, right? There is no single correct value without specifying a reference frame. Now, really quick, let's just do some quick examples. So let's say, for instance, that a 1500 kilogram car travels at 25 meters per second. Now let's calculate this kinetic energy. What we're going to do is we're going to use this this formula here. Kinetic energy equals 1/2 times mass times velocity squared. So that'll end up being 1/2 times 1500 times 25 to the power of 2. And that will end up, if we were to calculate it out, which I don't have my calculator handy, but it will end up coming out to about 468.75 kilojoules, right? Which is just, if we were to just put it in joule form, it would be, but we can, kilojoules, kilo obviously means 1,000, so the decimal would be here. We just move it up 3 points to make it kilojoules. 468.75 is our kilojoule value. All right, and that's the answer I would put for that.